All right, circumference and rotation problems. I'm actually going to fold my notes so we can just focus on these. So we've got 3 problems here that actually I'm probably going to need some graph paper. You might need some extra graph paper to be able to write this workout. So I'm going to shove some graph paper right here so we can work. It says a bicycle tire has a diameter of 62 centimeters. Guys, as soon as I see something like diameter of, I go ahead and in my brain, I'm like, if the diameter is 62, then the radius is 31. It's half of it. I may not need that, but I might, right? I might need the radius. I just go ahead and I think about it. What is the distance the bicycle tire travels in 10 revolutions? Well, guys, before we can think about 10 revolutions, we need to think about 1 revolution. So if we try to think about this, do I have a perfect circle on here? Yeah, and this is really small, so it'll work great. Guys, if we think about a tire, like a bicycle tire, and we think about how far it goes when it revolves once. Can't even fit my pen in there. Oh my gosh, I can't fit my pencil in there. 0.9 lead is too big. I'm afraid I'm going to break my pen. How far will go on 1 rotation if we think about like on the ground? What would that distance that we travel every 1 rotation be equal to? Please write down 1 rotation, and you can abbreviate it if you want. So if I'm riding my bicycle, right, the wheel spins once. I go that distance. It's the outside of the circular wheel. What does 1 rotation equal? To the question I'm asking right now? I don't want anything but the question that I'm asking right now. I need you to focus on what we're discussing together. So back up. If you're at the end of the problem, back up. Help us out. Can you answer what is 1 rotation? How far do we go in 1 rotation? You had to figure this out to get the answer. I don't want the number. I want like what we can talk about in the circle. Is it the area? Is the rotation of the circle the area? Is it the radius? What is 1 rotation? Yeah, Grace is saying it. If this is my wheel, this is going to get real funky for a moment, but this is the best idea I got right now because I didn't know we were going to get to this today. I'm glad we're getting to it today. If this is my wheel and it starts on the ground and I go, I'm going to back it up, 1 rotation forward. How far do I travel? What is this distance around the outside of the circle? What do we call that? Not the outside of the circle. The circumference. 1 rotation of a circle is equal to the circumference. So guys, that's like the most critical thing we need to be able to solve these problems. Is that when they talk about a rotation of a circle, they're talking about the circumference. So the first thing we should figure out is what is 1 circumference, and then from there, we'll be able to figure out what 10 of them would be. So the first thing we always need to write down is our formula. So C equals, we could say pi d, or we said we kind of like to say d times pi better. We know the diameter. Okay, sweet. Circumference. Diameter was 62 pi. So that is how far we, well, centimeters, right? Okay, centimeters. So I could, instead of writing circumference, I could write 1 rotation. And instead of saying 62 pi, since we're talking about distances, we should probably go ahead and get the decimal. So grab your calculator. Lost mine. 62 times, yep, 3.14. 194.68. Now guys, let's put this in perspective. The wheel, this gets really cool. I'm like, fun to think about. The wheel is 62 centimeters wide. That's like a normal bike tire, right? Like this wide, like a normal bike tire. I'm gonna come over here actually, so I'm on camera with Grace. So this wide is a normal bike tire, right? But 194 is about 2 of these. Almost to it. So the tire's only this big, but when it spins a full rotation, we go about the distance of 2 complete meter sticks. Because guys, remember, the circumference is about 3 times. It's about 3 times this, because it's over 3 times, right? Times 3.14. So we're more than tripling. But wait, we're not done. They didn't ask for 1 rotation. How do I turn 1 rotation into 10 rotations? Yeah, multiply by 10. You guys are brilliant. So, times 10 over here, and we will have to times 10 over here, which actually moves the decimal place. 1946.8 centimeters. So 1,000, put a comma, 1,946.8. Ooh! Round to the nearest, not a focus, round to the nearest centimeter. All right, that'll round up. Yeah, 1947 centimeters. Now the next problem kind of flips our order around. I'm going to scooch this paper over so that as we do the next problem, the fold of my paper is messing with my focus, I feel like. Both mentally and my camera. All right, so they start by telling us how far Stan drove. Total distance. Okay, great, but we don't know what that is yet. Stan drove 3,300 miles. Sorry, not miles. What's M stand for? Meters. The truck tires he has have a circumference of 2.2 meters. So remember, that circumference also means 1 rotation, right? If they tell us the circumference, they're telling us the 1 rotation. So if you want, make a little note that Stan's 1 rotation of a tire takes him 2.2 meters, right? A little over 2 of those. Meter stick we were just talking about. How many rotations did each tire make on Stan's drive? So, guys, if we think about 1 complete distance of 3,300 meters, and that's going to be like rotation. It's really weird to think about tires rotating as they travel a distance, because the tire itself, like the rubber, stays on the ground. You guys, think about if you had a point on a tire to watch as it goes up and down and up and down and up and down and up, right? If you had 1 point on the tire, it's going up and going down and going up and going. It's really weird to think about. How could we split up Stan's drive into how many rotations? Well, we know what 1 rotation is. They tell us 3,300. Guys, this is proportional thinking. Guys, this one rotation equals 2.2 meters. That is a ratio that we can write down. Please, with me, write down 2.2 meters for every one rotation. Equals 3,300 meters over some number of rotations that we don't know. Now, we don't actually have to do this since this is 1. This problem is actually not too bad. What we're looking for is how do I go from left to right? But we always said if we don't know how to multiply to go left to right, what could we do instead? If we don't know how to multiply, how do we figure it out? Divide, right? We divide backwards. So we're going to take his total trip, split it up to each rotation. Each rotation is 2.2. 1,500. That's kind of nice. So that tells us this is times 1,500. That is also what we do in the denominator. So this would be 1,500 rotations. Guys, and that's actually how they tell you how long your tires will be good for, is they do the math, and they know how many times it should be able to spin on the ground before it kind of wears away. So when they tell you these tires are rated for 40,000 miles, sounds like a lot, and it is a lot. And they've done the math for like how quickly does the rubber wear away. That's what this all comes down to, is how many rotations does the tire make. Here's a question to think about. When going the same distance, think about like your bike and your little sister's bike or whoever, when going the same distance, right, here to home, whatever, would a big tire rotate more or would a small tire rotate more? So think about that for a second. But what if you only have one tire, like a unicycle? Ben is riding a unicycle. The tire of his unicycle has a circumference. What did we say circumference also tells us? Rotation distance, right? Yeah, the outside of it, the rotation distance. So 2.8 meters. And the tire revolves 1.5 times per second. Ooh, that seems... Revolves 1.5 times per second. That seems pretty important. So every rotation of his unicycle wheel takes him 2.8 meters. Right? Every rotation takes him 2.8 meters. And it revolves 1.5 times every second. So we do our 2.8, they're telling us, is the one rotation. All right, let's make a note. That is one rotation. We could even down here say one rotation, 2.8 meters. We want to figure out 1.5 rotations, though, because that's how far it goes every second. How could I go from 1 to 1.5? Multiply, right? But by 1.5, right? How do I go from 1 to 1.5? Always multiply a 1 by the number we want. So 2.8, grab your calculator, 2.8 times 1.5, or 1.5, what do you get? 4.2. And they said that happens the 1.5 rotations is every second. So that's 4.2 meters per second. Any questions how I've gotten where I am now? All right, so then they ask us for 100 seconds. How could I get to 100 seconds? Yeah, I have 1 second. Let's take that and do times 100. Well, times 100 moves the decimal place. Right, so if we do times 100 to our time, we also have to do times 100 to our distance. So we get 420 meters per 100 seconds. Gentlemen, it would behoove you, especially since I'm recording, to just ignore that. Questions about the math? Guys, these problems are all about, don't try to solve it immediately, because a lot of times it takes a couple steps. We could not jump straight to the solution here. There's no easy, right? There's no easy route to get from 2.8 to 420 meters, right? Like we did a series of multiplications. We multiplied that 2.8 by 1.5 to get down to the 4.2. So that was times 1.5, because they had told us 1.5 times per second. Then we took that 4.2 and multiplied it by 100, because they told us 100 seconds. So first we did 1.5 rotations, then we did 100 seconds. It's a lot to follow, but our final answer, 420 meters. Any questions? All right, dudes. You can go ahead and put that away. I won't see you guys again until Monday. Check your email tomorrow and or Friday, because those are your at-home days. All right, Grace, same for you. Check your email, probably Friday morning. I may send you guys something to do on your own at home, because we all need to be at the same place on Monday, right? And you're going to miss about a half an hour of class time. Now, fortunately, my morning class didn't get to those last 3 problems, so you guys are technically ahead right now, because quite frankly, your small class is easier to manage. Some of you guys, some of your friends like to talk, especially this morning. We were pretty chatty because of St. Patrick's Day. So we are technically ahead right now, so good job, guys. For anyone watching this video out there on YouTube, that was only 3 problems of all the problems like this that we're going to do. So please email me if you guys have any questions as we try these circumference and rotation problems. We'll all be back Monday. All of us in the same building at the same time. It's amazing. Grace, have a wonderful rest of your day. If you need anything, send it to me in the chat right now, or send me an email because I got a class coming in. So thank you very much. Enjoy your St. Patrick's Day. I hope you're wearing green. I'm even wearing green socks. Look at this. But there's green on my shirt. I'm not Irish, so I don't really have any St. Patrick's Day stuff.